This is Tech Math 2. And it's day 1, and we're in chapter 1. Actually, it's day 2, but day 1 we just went over the syllabus. We're in chapter 1, and we're going to look at sections 1, 2, and 3. So that's the plan. Yesterday, we had something on the board that said the world has whole numbers. And we decided that those are things like 1, 2, and 3. And that the world has integers. And those are things like plus or minus 1, 2, and 3. Plus and minus 1,351. So those are our integers. And then after integers, we have rational numbers. And those are numbers that can be formed by one integer divided by another integer. So 1/2 would be a rational number. 1/3 would be a rational number. But so would 1, 2, 3, plus or minus 1, 2, 3. Those would all also be rational numbers. And then we have a set of things that are irrational. Irrational numbers, the square root of 3, the square root of 2, the square root of 5 would be all irrational numbers. Those are numbers that can't be in the form one integer divided by the integer. And then we have another set of numbers called transcendental. And that's pretty badly misspelled too. Pi would be a transcendental number. E, the base of the natural logs, would be a transcendental number. All these numbers together form a set of numbers that we call real numbers. So all the real numbers are the whole numbers, the integers, the rational, irrational, transcendental numbers. Then we have another set of numbers that are imaginary. Imaginary, A-R-Y, maybe. Yeah, that's pretty bad. Imaginary numbers, and they all have the square root of -1 as part of the number. And I just got a look by Nate, which was you can't take the square root of a negative number book, and that's true. But from 1820 on, we came up with imaginary numbers, square root of -1, and it's going to be an I, or it could be a J, or it could be a K. So we could have imaginary numbers in the X direction, in the Y direction, or the Z direction. We could have 3 coordinate axes of imaginary numbers. So the imaginary numbers sit over there. They're normally in the form X plus yi, something like that. And we'll have to deal with them too. And that makes all the numbers we currently know. There's no numbers that we know that we allow to have in our numbering system that aren't real or imaginary. Okay, happy about that? Yeah, and you probably learned that in 8th grade or so, maybe, something like that. Okay, so now we're in section 1. And we asked the awesome question, if I have -1 squared, what is it? Okay, so I take out my calculator and see, and I have -1 squared, and my calculator says what? It says it's -1. Wait a minute, -1 times -1 should be 1. Why is my calculator saying -1 squared is equal to -1? Why is my calculator so stupid? Well, my calculator isn't that stupid. My calculator didn't do that. If I wanted to do that, I would have to do that. -1 times -1 gives me a 1. But I didn't tell the calculator to do that. So when we're dealing with stuff, we have order we have an order of operation. Okay, and what happens first is what's ever inside parentheses. Okay, so if something's inside parentheses, that has to happen before something else has to happen. What happens next are powers. What happens next is multiplication and division. And what happens next is addition and subtraction. So when I have minus 1 squared, I have no parentheses, but I have to do the powers next, 1 squared. If I wanted minus 1, I'd have to do that. But I didn't do that, so that's not what I got. And then I do the negative sign last. So it's an order of operation, and my calculator is going to do those orders for me automatically when I put something in. So I put in 4 times 3 minus 1. So I put in 4 times 3 minus 1. The calculator isn't going to go and do this guy first and say that's 2 times 3 and gives me an 8. 2 times 4 gives me an 8. It's going to do 12 minus 1 and give me an 11. And yeah, it did. Gave me an 11. So the calculator is going to do the order of operation the way that is proper. Now, if it needs parentheses, you have to put them in. It might be that you have implied parentheses. 3 plus 4 divided by 7 plus 8. I have implied parentheses that say that addition has to be done first. 7 divided by 15. Okay, so that you say, well, I'm dividing. 3 plus 4 divided by 7 times that. I got to do the division first. No. The division bar gives you implied parentheses that you have to do first. Oh, isn't life wonderful? Yeah, pretty much. Okay, now we're going to look at problem number 8. And problem number 8 wants to know what is the absolute value of 1 minus a minus 6. All right, well, that begs the issue of what is absolute value. The absolute value of A. Does that look like an A? Yeah, that better. Absolute value of A. That's going to be equal to A if A is greater than or equal to 0. That's going to equal to minus A if A is less than 0. Okay, so the absolute value of minus 2, 2. The absolute value of 2, 2. Okay, so that's what absolute value means. All right, we probably knew that. Order of operations got a minus 6. I got minus a minus 6. That makes it a plus 6. Plus 6 and 1 is 7. Now, my calculator, I haven't gone looking for the absolute value sign. See if I can find it. No, I don't see it anymore. I didn't think it had one. Graphing calculator as well. Number 39. Number 39. All right. Plus 1/12 minus 1 2/3. Okay, well, if this were not a tech math class, it is, but if it wasn't, then what I would do is say, well, this is 1/12, and 2/3 would be 8 12s. 8 12s plus 12 more 12s would give me 22 12s. And then 1/12 minus 22 12s would be minus 21 12s. And then 3 goes into the top guy, minus 7 over 4. And that would be minus 1 3/4. So if this were a a math class taught by the math department, that's what you would do before it gives me the whole time. It shouldn't do that. Anyway, so that's what you do in a real math class. Well, this is a tick math class. So you take out your calculator and you have a fraction key above the 7. You see that key above the 7? And you have an improper factor key. That's second function 7. Okay, so I'm going to hit the key that looks like this, the box over box key. Okay, so I'm going to put a 1. I'm going to hit the box over box key and put a 12. Okay, and then I'm going to say minus, and then I'm going to go 1, second function, the 7 guy, and I'm going to put 2 divided by 3. I think I have to do it again, maybe. 2, 3, yeah. And then I'm going to hit the enter button. Boom. Syntax error. Stupid computer anyway. I'm going to do it again. All right, so 1, 12 minus. Okay, so is it let me think. Minus 1, 2, 3. Minus 19/12. Why don't I have minus 19/12? How can I have minus 19/12? Okay, so I use that key, and then, okay, so I use this key. I went 1. I used a key that looked like that. 2 minus 1. The second function key, the 7 button, and then I hit the 2, and then I hit this key again, and then I hit 3, and then I end up with minus 19 halves, 19/12. Now, I probably can turn that into an improper fraction, maybe. No. And I used to be able to do that. So that'd be a what? 1 minus 1 and 7/12. Okay, so what did I do wrong up here? 1 and 2/3. So that's 1 and 8/12. 1 and 8/12. 12 12s plus 8 12s is 20 12s. 20 12s minus 19. Okay, so that's why we don't do it the way the math department does. We use our calculator. Okay, now, we don't necessarily have to use the fancy keys, right? So we go 1 divided by 12 minus 1 minus 2 divided by 3. I don't have to use fancy keys. And I end up with, so I went 1 divided by 12 minus 1 minus 2 divided by 3. And I ended up with minus 1.58333 repeating. If I use my second function key, and you see the squiggly equal sign on the bottom, just above the enter key, that says F, arrow, arrow, D. If I hit that key, that changes my decimal number to a fraction, or my fraction to a decimal number. When I hit that key, I end up with minus 19/12. Okay, good enough? But we're making our calculator do the math for us. We don't necessarily have to do the math the way the math department would. I never do. Okay, well, Number 66, minus 3 plus 5 minus 8 plus 2 minus 1. I got 1, 2, 3 minus signs, so my answer is going to be negative. Okay, so I'll put that down, and then I'm just going to put it in my calculator, and I'm going to ignore all the minus signs because I'm that type of guy. 3 times 5 times 8 times 2 equals 240, minus 240. So I figure out that it's going to be negative when I get done, and then when I put it in my calculator, I don't worry about the negative signs. Okay, number 72. During March, Mary's small business had an income and had expenses. Find her monthly profit. Okay, so she made this, and she lost that. And her monthly profit is going to be a negative number. Can I do it in my head? Probably. 1875 minus 2055 minus 180. Is that correct? Probably not, because we're dealing with money. So that would mean a better answer would be minus $180, right? That would be a better answer. If you're an accountant, then a better answer would be in red in parentheses like that. But we're not accountants, so we don't have to worry about things like that. But a better answer would include, if you're dealing with feet or yards or meters, then you have to have units, right? So we're dealing with money, we have to have units. The unit is dollars. Okay? Now we're in section 1-2. And I find that if I add something, if I add 0 to some number, I get the same number. If I subtract 0 from some number, I get the same number. If I multiply by 0, I get 0. If A times B is equal to 0, then it must be true that either A is 0 or B is 0. I have no other choice. I can divide 0 by B and get 0, but if I do, B cannot be 0 yet. Not until chapter 21. Can't really be 0 then, but we have ways. If I take a number and I divide it by 0, I'm meaningless. N-E-A-N, meaningless. This is not allowed. Not allowed. And so that's and if I go 0 and I divide it by 0, then that's indeterminate. Indeterminate. So when we get to chapter 21, we'll see that if I have x divided by sine x, and I take the limit of that as x goes to 0. And I say, well, as x goes to 0, the top goes to 0, and the bottom goes to 0. You have to take my word for that. Okay? You don't really know that it goes to 0, because how would you know that? It's indeterminate because I have 0 divided by 0. L'Hopital's rule, which is, again, something we don't get to use until later on next semester, says that if I take the derivative of the top guy and divide it by the derivative of the bottom guy, I get the same answer. Well, the cosine of 0 is 1. This is 1 over 1. This becomes 1. So the limit as x goes to 0 of something that's 0 over 0 regularly, it ends up being 1. Just what you needed. So that's what this indeterminate means. Indeterminate means I'm going to figure it out later in another chapter. Dividing by 0 is meaningless. It's not allowed. I can't do it. Can't be done. Later on we'll say, well, the answer is infinite. But other than that, order of operations we already talked about. Okay, now we're going to do the problems in 1-2. And the first problem is problem number 3. And we have, I hope this comes on a quiz. 6 times 0 is 0. Speaking of quizzes, every Friday we will have a quiz. So, so it'll be fun. It'll be a riot. And of course I use the same exam bank, so sometimes the quiz questions end up on exams later. I really can't tell. Number 18. So I've got 3 divided by x plus 1, x minus 1. And what am I supposed to do with this? Find the values of x that make the fraction meaningless. Well, that's pretty silly, right? So what I'm trying to do is find the values of x that make this divide by 0, right? All right. So if x is 0, this is meaningless because I'm dividing by 0. If x is minus 1, then I'm dividing by 0. If x is 1, then I'm dividing by 0. Okay, do we like that answer? Of course not. Mathematics has a syntax associated with it. So my final answer, minus 1, 0, 1, because I put them in order. Or a final answer, x is equal to 0 plus or minus 1, that would be okay too. Now, all 3 of those I would count as correct. Okay, I'm just saying that these other 2 are more correct because I put my numbers in the right order. So if I were a 8th grade math instructor, my 8th grade math instructor was Mr. Skrubinsky. He told the class that all homework will be done in pencil. Now, we all know that my ability to follow instructions are slight, right? All my homework was done for the whole year in pen. It was all right. It was always 100%. I aced all of his tests. My final score in the class was a B. I'd failed to follow instructions. Yes. So I would have done this, if he said that to me, I would have done it this way on purpose because I'm that type of guy. Right? Okay. But that's neither here nor there. Right. So there's the right way to do it. There's my way to do it. And there's a math way to do it. Now in 8th grade, your grade doesn't really matter, right? So it's not like it hindered me anywhere else in the world. But it's just one of those cool things. 3x minus 6, 1 minus x. What the heck's x? Oh, we don't know. I remember. Minus 1, x minus 1, 2x minus 6. Find the values of x that makes it indeterminate. Okay, so now I need an x where I get a 0 on the top and a 0 on the bottom. All right, so that's what I'm looking for. So clearly, if x is a 1, I have a 0 on the top, 0 on the bottom. Can I make 3x minus 6 0 at the same time I make 2x minus 6 0? No, I won't be able to do it. So that's the only time that, wait a minute, which one am I doing? 34? I want an indeterminate. So yeah, I have to have a 0 on top and on the bottom. So the only time that would happen is in that case. The right answer here would be probably 2 over 3. Is probably the right answer. But we don't have to worry about that. Number 48, right answer is 1, is what it is. Okay, so 48. Oh, okay, so 48 divided by 4 divided by 3 times 6 minus 3 divided by 4 plus 2, 6 minus 2. Evaluate is what we're supposed to be doing. Okay, well, let's see. What do I have? We'll do the bottom guy first. 6 minus 2 is 4. 4 times 2 is 8. 8 plus 4 is 12. So I got a 12 on the bottom. All right. 48 divided by 4 is a 12. Divided by 3 is a 4. 4 times 6 is 36. 24. 24 minus 3 is 21. Both top and bottom is divisible by 3. 7 over 3. 1 and 2. No, can't be 7 over 3. 7 over 4. 1 and 3/4. All right. Am I right? I don't know. So I'll put it in my calculator. 48 divided by 4 divided by 3 times 6 minus 3. Boom. So on the top is 21. Okay. If I hit the divide button right now, it keeps my 21. I don't have to put it back in because it automatically puts the answer there from the guy on top. Parentheses 4 plus 2 parentheses 6 minus 2 close parentheses equals 1.75. Is that 1.75? Second function changed to a fraction. Boom. 7 over 4. Yeah. So my calculator said 1.75. Perfectly legitimate answer. There's no reason you have to put it in any other form than that. Perfectly okay. All right. Now we're up to, what are we up to? 48. We did 48. We're in section 1-3. And here we have scientific notation, power of 10. I take my calculator and I push the mode button, which is on the top next to the blue one. And I move down. I see there's a normal, and there's a scientific, and there's an engineering notation on my calculator. I put it in scientific notation. I hit the enter button. I go to quit. My calculator is now in scientific notation. Whatever I do, the answer will be in scientific notation. Okay, so that's good. Scientific notation is a number, a dot, a bunch of other numbers, times 10 to some power. That's what scientific notation is. Okay, and if I have 10, I have some rules. So I have a rule that says a to the 4th times b to the 4th is going to be equal to a to the 4th times b to the 4th. Those are two different things. I can't do anything with them. But if I have a to the 4th times a squared, I can add exponents and have a to the 6th. So like bases, I can add exponents. If I divide, I have a to the 4th divided by a squared, I can subtract the exponents and end up with a squared. If I have some base to the 0 power, I get 1. Okay, so in here, it all has to do with powers of 10. 10 to the m times 10 to the n is equal to 10 to the m plus n. And 10 to the m divided by 10 to the n is equal to 10 to the m minus n. And 10 to the m raised to the n, 10 to the m times n. Good enough? 10 to the minus n, 1 over 10 to the n. 10 to the 0 is 1. Okay, good enough? So now with my calculator in scientific notation, we want to do whatever the problems say to do. And we remember that scientific notation is always a good thing because then we don't have to count how many zeros I have or where I have to put the decimal point. When when I was a senior in high school, we had physics. In physics, we used slide rules to come up with our answers. The slide rules will give you the number. It'll tell you it's 2.4 as your answer, but it won't tell you the power of 10. You got to figure that out yourself, and we're using our fingers and our toes and whatever to do that. And when I was in college, for 4 years of college, we used slide rules. Did the same thing. You know, wasn't until graduate school, 4 years later, that I got my first calculator. 1978, $15. It add, subtract, multiply, divided. That's all it did. Well, that was useful. Number 9. Now you have a calculator that has more power in it than the first computer does. Number 9. 1 over 10 to the minus 4. Anybody have an answer? Now, if I put in my calculator 1 divided by 10, the double E key, the minus key, the 4 key, and I hit enter, what do you think it's going to give me? 1 divided by 10, double E, minus, not the subtract key, but the minus key. Those are two different things. It gives me 1 exponent 3. So it doesn't give me 10 to the 4th, it gives me 10 to the 3rd. So why did it do that? Well, I didn't put in this guy. That's my issue. What I needed to put in 1 divided by 1 double E minus 4. When I put in 10 double E minus 4, that's 10 times 1 times 10 to the minus 4, which is 10 to the minus 3, and that's why it gave me the wrong answer. 1 divided by 1 double E minus 4. Well, 1 E 4, 1 times 10 to the 4th. Okay, so don't, when you're putting the number in your calculator, don't put in an extra 10. Okay, so 2 times 10 to the 4th, you'd put in 2 exponent 4. 1 times 10 to the 4th, you'd put in 1 exponent 4. You wouldn't put 10 exponent 4, like I did, on purpose, to show you that I got the wrong answer. Yeah, sure he did. Yeah, and I wasn't born yesterday. He messed that one up pretty bad. Okay, so I got 10 to the 5th, 10 to the minus 2, 10 to the minus 6, 10 to the 3rd, 10 to the minus 4th, all raised to the minus 3rd. All right, well, I'm going to add exponents. 5 minus 2, 10 cubed. Minus 6 minus 10, 10 to the minus 7. 3 minus a minus 7, 10 to the 10th. Raise the 1, raised to the minus 3, 10 to the minus 30. All right. Is that spelled correctly? There's nothing wrong with that answer. Perfectly okay. Okay, but your 8th grade math instructor doesn't like negative exponents. So your 8th grade math instructor would have insisted that you do that, right? Yeah, she would have, or he would have. This is a tech math class. There's nothing wrong with that answer. Perfectly okay. But when you're dealing with your children as they go through elementary math and middle school math, don't corrupt them by your tech math knowledge. You know, make sure they answer the question the way their teacher wants it answered. That's going to be difficult, but just one of those things we have to do. Okay, number 30, 0.00012,102. Scientific notation. Looks like I've got one too many zeros. Do I have one too many zeros? Is that better? Okay, so I moved the decimal point 1, 2, 3, 1, 2, 3, 4 places. 1.02 times 10 to the minus 4. But my calculator is in scientific notation because I put it there. 0.000102. 0.000102. And my calculator gives me 1.02 e minus 4. Same answer. Capital E. Capital E means 10. Little e means base of the natural logarithm. So a little e means 2.7182881828. Going on for infinity, forever and ever. Never repeating. But a capital E on your calculator means it's a power of 10. Number 54. Oh, gotta turn the page. Oh, you gotta be kidding me. God. Well, we're not gonna write it down. We're just gonna put it in our calculator and see what the answer is. And of course, we'll all agree that I'm right, right? 3.86 EE5 times 5.51 EE minus 9 times 1.91 EE8 equals. Okay, then I'm going to hit the divide button. It's going to put the answer there from what I just did, but now I'm going to need parentheses on the bottom to make sure that everything stays on the bottom. 2.34 EE minus 4 times 1.35 EE6 times 9.05 EE10 close parentheses equals. Okay, so I've got a 1.29369,004 times 10 to the minus 8th. Now, there is something wrong with that answer. What is it? Well, in my problem, I only have 3 significant digits. So in my final answer, I should only have 3 significant digits. 1.29 times 10 to the minus 8th. And then we can say, did he get it right? Did I get it right? Anybody else put it in their calculator know that I got it right? So we don't know whether or not I got it right. Maybe I did, maybe I didn't. Okay.